Good morning, everyone. Today we are going to talk about dividing polynomials, but before we do that, let's get a reminder real quick by warming up with some long division. I want to divide this very simple expression, 137 divided by 5. If I want to do this with long division, remember that we set up the number that's outside, as we call the divisor, on the outside of this little bar, and put the other number, we call that the dividend, we put that inside. And what we're doing is we first look to see, well, how many times does this number 5 go into that first digit 1? Okay? And we say, well, we can't do that. So then we say, well, what about the next number, 13? How many times does 5 go into 13? And so you can do a little bit of division off to the side if you want to. We can see the 13 divided by 5. That's going to be 2, but it's going to have a remainder of 3. So we put the 2 up at the top. We multiply these two numbers. 5 times 2 is going to give us 10. We put that 10 down here. Remember, we want to subtract these two numbers. 13 minus 10 gives me 3. And so then we would say, well, how many times will 5 go into 3? And we say, well, it can't, obviously. So what we do is we bring down that next digit, 7. And we say, well, how many times will 5 go into 37? Again, you can do a little bit of that division over here off to the side. Some quick mental math is going to remind us that 37 divided by 5 is going to give us 7, but with a remainder of 2. So we say, all right, well, let's put the 7 up top. We're going to multiply these two numbers, 5 times 7, and that's going to give us 35. We then subtract the two values that we have here, 37 minus 5, is going to give us 2. And we can ask ourselves one more time, how many times will 5 go into 2? We say it won't, and there's nothing left here to drop down, so that means we're done. And the answer that we have is going to be this number up top. That's our quotient. But then the number down here, this is our remainder. And so instead of writing 27 remainder 2, we could have also thought about this as 27 and 2/5. So that's a quick reminder of how to do long division. Now what we want to do is carry that over to doing long division with algebraic expressions. So let's check it out. All right, so today's learning intention for dividing polynomials is to be able to do just that. Divide polynomials using two different methods. We're going to use long division, and we are going to use something called synthetic division. Your success criteria is going to you actually doing this division. So let's get to it with an example. Setting up the long division with algebraic expressions is exactly the same as we did with the numerical expressions. We take this part here and set it up on the outside of our division symbol. Then we take the first expression and we put that on the inside of our long division symbol. So we've got x squared plus 6x plus 12, and that is being divided by x minus 3. Now, similar to how we don't look at the entire expression at once, we're going to do the same thing over here. We're going to only look at it term by term. And we're really only primarily focusing on the x's because that's what we care about. Okay, so I look at x squared and I want to divide it by x. So we can do that off to the side over here. Now, x squared divided by x, if you don't remember how this is supposed to work, we can see this pretty simply that x squared is just x times x. And if we're dividing that by x, we recognize that we've got an x in the numerator and the denominator, so those can cancel each other out. So x squared divided by x gives me x. Now, once we've done this part, this is part of our quotient. So we put that quotient over here. Now, once we have that part of the quotient, we need to multiply that with the divisor. But we're going to multiply it with both terms. Okay? So we take x and we multiply it with the other x. X times x gives me x squared. Then we take that x and we multiply it with the negative 3, and that gives us negative 3x. Now at this stage, we would subtract these two expressions, but you're subtracting the entire expression, so we do need to put parentheses around it. Hopefully we can remember from some of our last lessons that when we are trying to subtract these expressions, we end up doing some sign changing. It's like that negative distributes through and changes all of the signs. And I like doing it in this way because now it shows me that I can just combine all of the like terms that I have. You can see I've got x squared and negative x squared, and guess what? Those are opposites of each other. They're going to cancel each other out. Now I've got 6x plus 3x, and that's going to be 9x. Now before I move on, I do want to bring down the next expression, divide that, or we want to bring down that 12. And now we repeat the same process. We look at term by term, and we take a look at 9x and divide it by that first term of our divisor, and we divide those off to the side here. So 9x divided by x, the x's are going to cancel each other out, leaving us with just 9. And that's part of our quotient. We put the quotient up on top. You can highlight those over here just so you can see where those are coming from. And now, just like we did before, we take that part of the quotient and we multiply it with each part of our divisors. So we take 9, multiply it with x to give us 9x. We take 9, we multiply with negative 3, and that's going to give us negative 27. We subtract these two expressions, but remember you're subtracting the entire thing. You're going to distribute through that negative sign to each one, meaning your signs all change. Now, just combine your like terms. The 9x and the negative 9x, so those are going to cancel, and that's going to happen every single time. 12 plus 27 gives us 39. There's nothing left over here to drop down, so that means, hey, we're basically done. We can just double check to see, does the 39 and the x, are those going to have any common factors in them? Are we going to be able to divide those at all? No, since we have a term with x and we have a term with no x, then that tells us we're done. What that means is this 39, that's our remainder. And the answer that we have is this part up here, that's our quotient. So how do we write everything out? We know we're done when we've got a quotient and we've got a remainder, and then we can write them out. So we write our quotient first, x plus 9, but then you want to make sure you're including the remainder as well. And remember that the remainder is always divided by the original divisor that we had, x minus 3. And this is our ultimate solution. So that, in a nutshell, few minutes, is polynomial long division. Very similar to what you actually did, it just looks really gross and it's a little bit more of a headspace. But this is sad times for real, right? Given the choice, I would never do polynomial long division. There are some cases in which we have to do it, but there is a faster way. And that faster way is something called synthetic division. So I'm going to show this off to the side here. I don't want you to actually write anything down yet. I just want you to look, watch, and absorb and see how we're going to do this. Because synthetic division is a little bit backwards. So I'm keeping this here so we can see my final answer. Now I'm going to take the same expression and divide it. But instead of dividing by x minus 3, I want to cheat the system a little bit. Only look at the coefficients. Okay, so that means I'm not going to be dividing by x squared plus 6x and plus 12. I'm only going to be dividing by 1, 6, and 12. And I'm not going to divide by x minus 3. I'm only going to be dividing by the coefficient. But again, like I said, I want to do it a little bit backwards. So I'm actually going to divide by 3. And I'm not going to use this traditional long division symbol. I'm going to do it upside down. Okay, it's a little bit backwards. So the first step is setting it up like this, where we use only the coefficients and we use the opposite sign of that coefficient that we were originally working with. I'm going to bring down this 1, and I'm going to multiply these two together. 3 times 1 will give me 3. Again, you can see how it's a little bit backwards. Instead of dividing, we're multiplying. Instead of subtracting these two values, 6 and 3, I'm going to work a little bit backwards. I'm going to add them together. I repeat the same process. I'm not going to divide. I'm going to multiply. 3 times 9 gives me 27. I'm not going to subtract these two values that I do in long division. I'm going to add them, and that gives me 39. And now hopefully we can start to see where we have a coefficient of 1, 9, and 39. We have 1, 9, and 39. So what that shows me is that I have a remainder, a constant term, and an x term, a coefficient of x. So that shows me my answer being x plus 9 plus 39 divided by my original divisor, x minus 3. So this way, while a little bit trickier, not obvious, is actually much faster. And if I've got the option, I'm going to be doing synthetic division every time. So let's teach you how to do it. Take a moment to pause the video, rewatch anything that you need to before you move on, okay? And copy down these steps off to the side of example number 2. So hit play when you're ready to start. All right, so the first step that we actually want to do in synthetic division is setting everything up, because again, this is a little bit of a tricky process, but the more steps you do, and actually the longer the problem is, sometimes the easier it is to wrap your brain around it. So we start off by trying to figure out what's going to be the number that's on the outside. What's our divisor? And as we said, instead of doing just using the entire expression, we want to work a little bit backwards. Here's the formal way of doing it. We're basically trying to see, is this x minus k going to be a factor, which means that it'll divide out easily and we can set it and make it a solution and set it equal to 0. Well, in this expression, if we match these up, that's like x minus 2. And we're trying to see, if we divide out x minus 2, will we get a remainder of 0? Well, instead of looking at it that way, I'm going to look at just looking at the number. So in this case, the k has that position 2. Okay? So that's step 1. Figure out what's on the outside. Now, once we've done that, we're going to look at only the coefficients. So my coefficient here is 1. My coefficient here is negative 2. And my coefficient here is 2. I set those up in that upside down division symbol. We have 1, negative 10, and positive 2. And now we can use these steps over here. Bring down the first coefficient. Step 2, multiply by k. So we take the 2 and we multiply it with the 1. 2 times 1 gives me 2. I'll put that right underneath the next coefficient. Step 3, add these two numbers. You're just combining them. That's it. Negative 10 plus 2 gives me negative 8. Step 4, repeat. Do the same thing. We've already brought down our coefficient. We multiply by k. 2 times negative 8. That's going to give me negative 16. Step 3, add these two terms. 2 plus negative 16 gives me negative 14. That's it. There's no more terms to bring down. So we're almost done. We just need to write out the solution. So what we want to recognize here is that this number is going to represent the remainder. The next number is going to be the constant. And then the next number after that is going to be the coefficient of every subsequent x term. X to the first, x to the second, x to the third power, so on and so forth. In this case, we only have one term, so that's going to be an x to the first power. So all of these are just coefficients to each one of these. So that means we have one x to the first power, which we can just write as x, a constant minus 8, and then our remainder minus 14. But remember, our remainder should always be written as being divided by the divisor. And this is our solution. And that's it. Pause for a moment. Rewind if you think you need to watch the steps again. Really try and watch and make sure you're following all the numbers and all the steps. If you're ready to move on, resume the video and go on to the next example on the back side of the page. All right, we're ready to tackle another one. Our first step is to find out that value of k that we're trying to actually determine. So remember that we are actually looking at just the opposite sign of this. We're trying to see if x minus k is going to give us a remainder of 0. That's the whole point. And in this case, we have 2 is in that position of negative k. So that means k must be negative 2. Hopefully what you're seeing here is that k is just going to be sign change. That's it. We take that positive 2, we make it negative 2. That's the number that goes on the outside. Then we draw our upside down symbol, and we look at just the coefficients. So the coefficients of our first term, we get 1. Next term, we get 4. Next term, we get 6. And next term, we get 4. Now we can actually do the synthetic division. Step number 1, bring down the first term. Step number 2, multiply with k. Negative 2 times 1 gives us negative 2. Pop it down here. Step number 3, add these two. 4 plus negative 2 gives me positive 2. Step 4, repeat. Multiply with k. Negative 2 times 2 gives me negative 4. Add these two. 6 plus a negative 4 gives me positive 2. Repeat. Multiply. Negative 2 times 2 gives me negative 4. Add these two. 4 plus negative 4 gives me 0. There's nothing more to do. We recognize what each of these different components are. This is our remainder. This is our constant. This is our x term, the first x term. Now, since we have one more term after that, this one is just going to be the next degree higher. So if this was our x to the first term, then that means this is going to be our x to the second term. And remember that these are all of the coefficients that we have of the expression. So that means we have 1x squared plus 2x to the first power plus 2. And we have remainder 0. So that means we're done. And that's it. So we did all that polynomial long division with very little actual writing. Now, a couple of important things to note that we want to notice here. When we have remainder of 0, this is a very special case. This is what's known as the remainder theorem. When the remainder is equal to 0, that's a big deal. It shows that the thing that we were trying to divide by, x plus 2, is actually going to evenly divide into this polynomial, which means x plus 2 is a factor of this polynomial. And that, again, is what we call the remainder theorem. Whenever you are dividing by a polynomial and you get a remainder of 0, then the thing that you divided by is indeed a factor. And that's going to be very important for us when we try to start solving polynomials. Okay? Again, if you need to look back at the video and watch through the example to see how we did it, please go ahead and do so. Otherwise, let's tackle another one. Now let's try and move a little bit faster. First step is to find the number that goes outside. We recognize now, hopefully, that this value k is just going to be the opposite sign of what we had before. Then, set up the upside down division bar. Start including all the coefficients. Bring down that first term. Multiply with k. 4 times 2 gives me 8. Bring it below that next coefficient. Add those two. Negative 11 plus 8 gives me negative 3. Repeat the process. 4 times negative 3 gives me negative 12. Add these two. 11 plus a negative 12 gives me negative 1. Repeat. Multiply k with that value. 4 times negative 1 gives me negative 4. Add these two. 4 plus negative 4 gives me 0. Repeat. Multiply. 4 times 0 gives me 0. Add these two. 4 plus 0 gives me 4. This term, my remainder. This term, my constant. This term, my x to the first. This term, my x to the second. This term, my x to the third power. Write out your result. 2x to the third minus 3x squared minus 1x to the first power. For the constant, we don't need to write it. We can just skip it. We can leave that gap there. That's okay. But the remainder, plus 4, we want to write it over our original divisor, x minus 3. And there's our answer. Now, applying that remainder theorem back, was our remainder equal to 0? No. So what does that mean? That means x minus 3 is not a factor of this polynomial. It will not divide in evenly, so this would not be super helpful for us as we move on. Last question. Here's the brain breaker. So if you need to pause and rewatch any part, please do so at this time. If not, let's get to it. What is the value of k such that negative x to the fourth plus 5x squared plus kx minus 8 divided by x minus 4 has a remainder of 0? You might not even know what this is asking, but recognize what the problem is actually suggesting that you do. It's suggesting we divide. So divide. Start off by finding our value of k. We change the sign. It's 4. Set up your synthetic division. Start writing out your coefficients. But be careful. We have negative 1x to the fourth, but where is the x to the third term? We have a gap. This happens actually quite a bit. There's a 0x to the third. We need to account for every single coefficient, every single time that a variable has an exponent, we need to account for those, even if that coefficient is 0. So we need to make sure we include that 0 as well. We then have 5x to the second power, so we didn't skip one. We have kx. That's okay. Put the k in there. And then we've got negative 8. Go through the process. We know the steps by now. Drop that first term. Multiply these two. 4 times 1 gives me, oh, this should be a negative 1, excuse me. And that means negative 1. 4 times negative 1 gives me negative 4. Clean up a little bit here. Negative 1, and then that gives me negative 4 when we multiply those two. Add these two terms. 0 plus negative 4 gives me negative 4. Multiply. 4 times negative 4 gives me negative 16. Combine. Add them together. 5 plus negative 16 gives me negative 11. Multiply. 4 times negative 11 gives me negative 44. Combine these two. Add them. They're not like terms. That's okay. We have k plus a negative 44. Go through the process. Do the same thing. Multiply. 4 times k minus 44. 4 times k, that's easy. 4k. 4 times negative 44, we might need a calculator for it. You could bust it out, but that's going to be negative 176. Now, next step. Combine these two together. The only things that we have to worry about, though, are the like terms, the negative 8 and the negative 176. And that's 4k minus 184. When we combine the negative 8 and the negative 176, we get negative 184. And so you might think, okay, well, that means we're supposed to be done. So do we write everything out at this point? Well, what were we supposed to do in this question? We're supposed to find the value of k such that we have a remainder of 0. Which part of this is our remainder? This part is our remainder. And our remainder is supposed to equal 0. So what that means is we can write this as an expression that our remainder, 4k minus 184, must equal 0. Now this is Algebra 1 stuff. Let's solve for k. We do that by adding 184 to both sides. 184s, they cancel each other out. We've got 4k equals 184. Divide both sides by 4. Again, calculator time. We know the 4s are going to cancel out. But now we've got k will equal 46. And now we found that value of k. That gives us that remainder of 0. And that's going to do it for today, guys. With the time you have remaining, you can work through the practice set of problems that I've provided for you. You can use synthetic division for each one. We can revisit our success criteria and learning intentions for today as well, reminding ourselves that we have learned how to divide polynomials using long division, but we say, hey, let's not do long division if we don't have to. Let's use synthetic division. It's a little bit more, it's not quite as intuitive, but it is considerably faster. All right, thanks for watching and sticking with us. Have a wonderful day. I'll see you in just a little bit.